Okay, so let's start this lesson 1.3, which is about the sum of an arithmetic sequence. And the situation we're looking at is the super stairs. Dan likes to walk stairs for a workout. When he's like a light workout, he climbs up and down the stairs one at a time. And once an more intense one, he does something called the super stairs workout, which is on this video. So let's see what happens here. So a normal stairs workout, okay, it looks like he's just climbing the stairs and heading back down. Pretty simple. Makes sense. But a super stairs workout is a little different. Let's see what he does here. 1, 2, 1, 2, 3. Okay, so I think I see what's going on here. 1, 2, 3, 4, 5. Then he goes down 1, 2, 3, 4, 5. Okay, so on and so forth. So it looks like what he's doing, it looks like what he's doing is going up one stair. He's going up one stair and then down one stair, up two stairs and then down two stairs, up three stairs and then down three stairs. And he's doing that up until he gets to the top. I don't know how many stairs that was, but it goes up that many and then down that many, and I guess he's done. Right? So it says if Dan found a staircase consisting of only three stairs, how many steps would Dan take to complete this super stairs workout? And it says here that going up one and down one is 2 steps. So let's draw a little picture here and show our work. How many steps would this take? 1, 2, 3. There's our little picture, right? And let's think about this. Well, first he's going to go up one, and then he's going to go down one. See? Then he's going to go up two, and then down two, right? And then he's going to go up three, and then down three, 3 and 3. And let's see, if I add those together, 1 plus 1 plus 2 plus 2 plus 3 plus 3, I'm going to get 12, right? Well, 1 plus 1, I'm just going to call that 2, right? 1 plus 1 is 2. 2 plus 2 is 4. 3 plus 3 is 6. So that's 12, right? And so it looks like however many steps he has to go, we're going to go, 2, then 4, then 6, then 8. If there's another stair, then 10, then 12, so on and so forth. Well, what if there's 8 stairs? At Dan's house, he has a staircase with 8 stairs. How many steps would he take to complete that workout? Well, continuing this pattern, this 2 plus 4 plus 6 pattern, right? Well, one stair only took 2 steps because I had to go up and down. Two stairs took 4 steps, then 6, then 8. And where am I going to stop? Where am I going to stop? Well, if there's only 8 steps, I'm going to stop at 16, right? Because I'm going to go up 8 and then down 8. And that is going to be the end of my workout. Now, I could just add these numbers up pretty easily by just putting them into a calculator, but let's try something a little different. I'm going to take this 2 and this 16. I'm going to add the outside ones first. 2 plus 16 is 18, right? 2 plus 16 is 18. And look, there's a 4 and a 14. That's also equal to 18 when I add those numbers. How about a 6 and a 12? That's also 18. 6 plus 12 is 18. And so is 8 plus 10, right? And how many times did I get 18? I got 1, 2, 3, 4 sets of 18 by adding the first and the last number, the second and the second to last number, the third and the third to last number. I ended up with 4 times 18 steps, which is 72, right? 72. Okay. And know where I got those steps. I got 18 by adding the first and last. And then I just had to multiply that by 4, which ended up being just half of the number of stairs. Half the number of stairs, and that gave me 72. So if I wanted to extend that idea to the super stairs at school, which is in the video, there were 21 stairs. How many times would I have to do this to complete this super stairs workout? Well, all I have to do here, right, is just continue this pattern. I'm going to go 2 plus 4 plus 6 plus 8, and so on and so forth. I'll get to 20, 22, 24, and then all the way up to 40, and then 42. And that will be how many steps it'll take to do 21 steps, right? Because I have to go up and down. Okay. So how many is that? Well, let's use the thing we just did in red, right? Let's use this idea. Let's add the first and the last numbers. 2 and 42 add to 44. 4 and 40 add up to 44 as well. 6 and, well, I guess over here would be a 38. That's also a 44. How many 44s am I going to get? Well, I'm going to go up to 20 and 24. That's another 44, and I'll do that after 10 of those. But look, there's this 22 in the middle. It doesn't have a partner. So it looks like it's going to be 10 times 44, but then plus an extra 22. In other words, that's just 10 and a half times times 44. You noticing that? 10 times 44 is 440. 22 plus 22, that's 462, which is the same thing as 10.5 times 44. Okay. So it looks like all we have to do to add up this sequence of numbers is add the first number, add the last number, and multiply by half the number of steps I have. When I had 8 steps, all I had to do was multiply by half of 8. When I had 21 steps, I had to multiply by half of 21, which is 10 and a half. I see. So all I have to do is take the first number and add it to the last number and multiply by half the number of steps. So if I have n stairs, then I would start with 2, and I would add up the last number. In this case, it would be 2 times n plus 2n. I'd take that number and I would multiply it by half the number of stairs. Well, that's just n over 2. 2 plus 2n times n over 2. And let's try this, right? Let's try this with our number 8, right? When I add 8 steps, n equals 8. And so if I plug that into this formula, I'm going to get 2 plus 2 times 8. Or sorry, 2 times 2 plus 8. Or sorry, yeah, 2 times 2, 2 plus 2 times 8. Oh, goodness. Times 8 over 2, right? So now this is an 8 and this is an 8. And if I plug this all in, well, that's going to be 2 plus 16. And 8 divided by 2 is 4. Oh, wait, that's just 72. All right. So today's lesson is about finding the sum of an arithmetic sequence. If you notice up here, these sequences that I've drawn in blue, 2 plus 4 plus 6 plus 8 plus 10 and so on, that's an arithmetic sequence, right? We're going up by 2 each time, but then I'm adding up all those terms. Same thing here. I've got 2 plus 4 plus 6 plus 8, and I'm adding the numbers up all the way until we get to 42. So I'm taking an arithmetic sequence and I'm adding up all of the numbers in it. I'm summing them, right? Taking the sum. Here is another example. Let's say I have this sequence 2, 5, 8, 11. Now this time I'm going up by 3 each time, right? 3. So first off, what is the 8th number in this sequence? Well, this is easy enough to find out, right? I can just continue, right? So if I'm going up by 3 each time, I'm going to go 14, 17, 20, 23. Right? So a number 8 is 23. That's a 8. And if I wanted to sum these all together, I could just add them all up on my calculator. 2 plus 5 plus 8 plus 11 plus 14 plus 17 plus 20 plus 23. Throw that into a calculator, right? Or I could use my trick and add 2 and 23. That's 25. 5 and 20, that's another 25. 8 and 17, that's another 25. 11 and 14, that's 25 as well. 25 plus 25 plus 25 plus 25, that's 100. Okay. And how many times did I add that up? Look, only 4 of those. Curious, right? Because 4 is half of 8. What if I want to do all the way up to the 33rd term? I don't want to draw 33 of these numbers, right? So first, let me figure out what the 33rd term is. Well, I'm starting from 2, and then I have to add 3 plus 3 plus 3 plus 3. I have to add 3, but how many times do I have to add 3? I have to add it 32 times, right? 2 plus 3 times 32, that's 98. So the 33rd term is 98, okay? But now I can use this trick again. I can use this trick. I'll take my first number, okay? This time I'm going to write this in red. Let's take my first number, add it to my last number, which is an, and take that number and multiply it by half of n. So in this case, it's going to be 2 plus 98 multiplied by whatever half of 33 is, because 33 is n, right? This is n. So 2 plus 98, that's 100. 100 times 33 over 2. Throw that into my calculator, or I can do it in my head, but it's 1650, 1,650. The first 33 terms of this sequence add up to 1,650. Okay? Now, if I want to add up all of these numbers, I don't want to have to write 2 plus 5 plus 8 plus 11 plus 14 plus, I don't want to do that. I don't want to write all of those terms. Let's come up with a shorthand to do that. We'll use a Greek letter. This Greek letter here, it looks like a sideways M. This is the Greek letter sigma. It's a capital sigma. And sigma is the Greek letter for S, and we're using that because that stands for a sum. Okay? Let me show you how this works using this example down here. Okay, then we'll describe this general idea here. Okay, so above the sigma and below the sigma, you will find two numbers, 1 and 6, and you'll also find a letter J. What this means is I need to take these numbers, 1, 2, 3, 4, 5, and 6, so all of the numbers, the whole numbers from 1 to 6, and I need to substitute them into this expression here inside of the sigma. Then I'll add those numbers up. Let's see what I mean, right? So J is going to run from 1 to 6. So if J equals 1, then this expression inside the sigma is going to be negative 3 plus 4 times 1. That's when J is 1. Right? See, I've just taken this J and I've replaced it with a 1. Well, negative 3 plus 4 times 1 is 1. Okay, now let's do it for 2. Negative 3 plus 4 times J. Now J is 2, so I'm going to put a 2 there. Which is negative 3 plus 4 times 2 is 5. What about when J equals 3? Negative 3 plus 4 times 3. Well, that's going to be 9, right? This is 12. This is -3. -3 plus 12 is 9 using BEDMAS. When j is 4, I'm going to do 4 times 4 minus 3. That's going to be 13. When j is 5, that's 17. And when j is 6, that's 23. And this entire expression is just what do I get when I add up these numbers? That's what we mean when we have S with a subscript 6. It's the first 6 terms added together of a sequence. What sequence? This sequence. No, this is arithmetic. I'm just going +4 each time. Right? This is an arithmetic sequence. So I'm summing the terms of an arithmetic sequence. And I'm expressing it through this, our explicit formula. Let's actually get the sum before we move on, okay? So the first 6 terms of this sequence is 1, 5, 9, 13, 17, and 23. This is the sequence given by this explicit formula. Okay. When I add those together, what do I need to do? Well, when it's just an arithmetic sequence, I don't have to add them all up individually. I can just use our trick from earlier. First plus last divided times number of steps over 2. So let's do that. 1 plus 23, so first plus last, times the number of steps, that's 6 divided by 2. So that's 24 times 3, which is 72. Okay. And look, if I add up these numbers together, these 6 numbers, and put them into my calculator, I didn't actually need to add them all up. I just needed the first and last. So let's label our diagram here. Give ourselves a little more room here. Okay. So what do all of these letters mean? Let's figure it out. So SN is simply the sum of the first n terms of a sequence. Of what sequence? The sequence given by this explicit formula. So in this case down here, that explicit sequence was -3 plus 4j. J here is a placeholder variable. It is just telling us what we need to change every time we go up by 1. Which means that the explicit rule has to be in terms of j. Okay? N is the last term. Okay? It tells us how far in the sequence we're going. These AI, these AJs, right? These are actually the terms being added. Okay, in our example, these AIs were the 1, 5, 9, 13, 17, and 23. That's a little confusing. There's a whole bunch of stuff going on here. Okay, so we're going to get some practice. Let's try some of these problems. Let's find the sum of the odd numbers from 1 through 100 without using a calculator. Oh boy. 1 through 100 without using a calculator. What are the odd numbers? Well, that's going to be 1 plus 3. That's an odd number. 2 is not odd. Plus 5, plus 7, plus 9, all the way up to 99. Okay. I could use sigma notation to express this, which we'll do in a moment as practice, but right now it's just asking us to find this sum. Well, I could do that using my calculator, but I don't want to type in all of these numbers. Okay, so instead, all I need to do is figure out the first number, the last number, and how many steps there are. Well, since I'm only taking the odd numbers from 1 to 100, we realize that how many of these numbers are there? There's 50 of them. So this is A1, A2, A3, and so on. And number 90 and 99 is A50, which means that finding this sum is as simple as taking the first plus the last, 1 plus 99, taking that number and multiplying it by the number of steps, 50 over 2. 1 plus 99 is 100. 50 over 2 is 25. 25 times 100 is 2,500. Okay. How could I write this as sigma notation? 1 plus 3 plus 5 plus 7 plus 9, all the way up to 99. How could I write this using sigma notation? So this is a bit of extra practice. Well, first let's draw my sigma and figure out what the upper and lower bounds are. I'm starting from 1 and I'm going all the way up to 50. So J is how many terms are the terms I'm going to use. So I'm going to start from 1 and go all the way to term 50. What is the expression that I need to use, though? I need an explicit formula for this sequence. I can't just use an implicit, or sorry, a recursive formula for this. Okay. Instead, I need something so that when I plug J into it, I'm going to get these numbers back out. Well, to get this first number, I'm going to do 1 plus, and then however many steps I need, times my common difference. I'm going up by 2 each time. One plus J minus 1 times 2. Let's just test it. If I plug in J equals 3, I do 1 plus 3 minus 1 times 2, I'll get 1 plus 2 times 2, that's 5. And is that A3? Yes, it is. Okay, so good. This is my explicit formula. That is what I want to put in to my sigma notation. 1 plus J minus 1 times 2. And if you try plugging in J equals 1, J equals 2, J equals 3 into this all the way through, you're going to get 1, 3, 5, 7, and so forth. And try it. Try it for the first few. Try it for the first few numbers. Okay, but that's a little bit of extra practice to get a handle of what's going on with the sigma notation. Let's list the first 6 terms of this arithmetic sequence and find the common difference, okay? So the first term is number 7. Just says so. Next, it's saying that in order to get the nth number, we need to take the n minus 1th number and add 4. So I add 4 and I get 11. I'll add 4 again, I'll get 15. I'll add 4 again to get 19, add 4 again to get 23. and add 4 again to get 27. There are my first 6 terms. Okay. What about A15? To get to A15, well, in order to get to A15, I'll start from 7, right? Here's my 7. And then I'll have to jump, let's see, 1, 2, 3, 4, 5, 6, and so on. I'm going to have to jump 14 times, 14 steps later, right? Because I'm starting at 1 and I need to get to 15. So I need to jump 14 times. I'll add 14 times my common difference, which is 4. 7 plus 14 times 4. Let me think about this. Well, 14 times 4 is whatever 40 plus 16 is, so 56. So 7 plus 56, that's 63, I believe. 63. Okay? Now I need to find the sum of those first 15 terms. Okay, so I need to find the sum of all of these. Well, as we saw earlier, I don't need to find all of the terms. All I have to do is take the first and the last term and add those and then multiply that by something. See? So the first term is 7. The 15th term is 63. I'll add those and multiply by half the number of steps. Or sorry, half of the nth number. 15 over 2. 7 plus 63 is 70 times 15 over 2, which is 7.5. And this is equal to, let's see, 490 plus 35. I believe it's 525. We should double check this though. That means that the first 15 terms of this sequence here add up to 525. We're almost done. Let's get a little more practice with this summation notation and actually figure out what we are talking about, okay? Here's an expression. So we've got 2j plus 4 as j runs from 1 to 4. So let's replace j with each number from 1 to 4 and add them up. 2 times 1 plus 4. 2 times 2 plus 4. 2 times 3 plus 4. 2 times 4 plus 4. That first one is 6. That next one is 10. Sorry, not 10, 8. This third number is 10. This fourth number is 12. If I add these all up, I'll get 36. So the sum from j equals 1 to 4 of 2j plus 4 is 36. Okay, let's try this here. Now, I don't want to write out 7 terms, so let's just write the first term and the last term, because we know that we're going to go from 1 to 7. Okay, 18 minus 3 times 1, that's the first term. Then there's going to be a bunch more terms, and then I'm going to end up with 18 minus 3 times 7. 18 minus 3 times 1 is 15. 18 minus 3 times 7 is negative 3, I believe. Now let's use our trick from earlier. The sum of the first n terms of an arithmetic sequence is just a1 plus an times n over 2. So in this case, 15 plus negative 3 times, what is n here? It's 7, so 7 over 2. I'll throw this into my calculator. I'll get 12 times 7 over 2. That's 42. 2. There's a way to do this on the new NumWorks calculator. Okay, so let me show you. If I go to NumWorks, go to my calculator, and I hit the toolbox option, a menu will pop up, and I can navigate this menu using my arrow keys. I'll go down to calculus. I don't need this first stuff. We're not going to deal with that until we're actually in calculus class. But here, if I scroll down to the bottom of this menu, there I will find my summation notation. I'll hit OK, and now I can fill in the gaps. Now the calculator uses K instead of J. That's totally fine. Let's just replace K with J. No problem. Now let's just copy this expression, whoops, this expression into my calculator, 18 minus 3J, as J goes from 1 to 7, or in this case, K. Okay, so this guy will go from 1 to 7. 18 minus 3. How do I get this K? Okay, because we're using K instead of J. Well, I'll hit my alpha button, which will give me access to the gray letters on these buttons. See those little gray letters there? And I'll hit this number, which gives me a K. And then all I have to do is hit execute. And I should get 42, the number that we calculated earlier. And there we go. The sum of this expression from 1 to 7 is 42.